And then comes a busy slide. This is the whole ecosystem of the world in big data, a part of the world, if you would say, still not the complete world. But this is a good representation of all the things happening in the big data. So what we're going to do, we're going to take next few minutes and just going to talk through this. It is a busy slide, but bear with me. Once we are done with that, hopefully you'll be able to understand most of it at a high level, right? At least at this high level. So you understand why we use big, why is this, why is that, all that will be answered. So let's start with that. So first is HDFS. We talked about it briefly. The good news is we talked about this one just now. It's the storage thing. Any data which comes to Hadoop goes in here, majority of the time. There are some exceptions, but majority of the time it's going to go in the Hadoop distributed file system. That's the bottom thing. The next one is MapReduce. You're going to process the data. You do the ranking. You're going to do the recommendation engine. Whatever processing you may be doing, that's going to happen in this layer, the MapReduce layer. And MapReduce is V2 is version 2. There was a version 1. We changed it to version 2. There was an enhancement. All that happened. Hadoop 1 was there, and now we are into Hadoop 2. And that's what. So any company when implements it mostly has these two components going on, at least. Right? So these two things are happening. But there are other components which are part of this. What happens, what I told you, Hadoop is not the creator of the data. The data is coming from somewhere else. So if it has to come from somewhere else, there has to be a vehicle, there has to be a mechanism which brings the data. And these two blocks on the left side are that. The blue color block of Scoop is helping us bring data from the relational world. Relational means all the databases. Previously, all the data before Hadoop was mostly stored in the databases. So we want the data, or many of the companies want the data to be brought into Hadoop. So how do we do that? So there is a tool called Scoop. The word Scoop stands for a combination of two words. So SQ stands for SQL, and OOP stands for Hadoop. So when you zap those two words, SQL plus OOP, it becomes Scoop, right? So that helps you to bring the data from Oracle, SQL Server, any relational databases you want to bring that data, you bring that and put it into HDFS. But the power of big data is not about structured data. It's about unstructured data. Those text files, the XML files, all that crazy videos, all that thing which we had, that's the power. So to get that kind of a data, we have a tool called Plume. So Plume helps us to get unstructured data in a form of, is called as a log collector. Let's say you go to a website, you click on 5 buttons, right? You see a product, oh, nice dress, and you don't order it. What happens tomorrow? They send an email. Oh, you were interested in the dress, but you didn't complete the order. Do you need some help us to do that? And you wonder why, how did they get that, right? You didn't even submit the button or something. No, they're tracking everything. They're tracking every single click which you are doing, which is called as click stream. So every single click is captured and stored in a log file. And Plume kind of thing can help you bring that into HDFS. So these are the vehicles which will help you bring the data from and the unstructured world. These are two things. One of the data you can store in HDFS, you can process in MapReduce. MapReduce is all Java. In Java, so not everybody likes it because everybody doesn't know Java. So how does everybody use Hadoop? So to make that happen, there are other kind of programs which were written. The program something called as Hive. Hive is a high-level program written on MapReduce. It's based on SQL. SQL query. Select star from employee. So you write a simple query and it sends a MapReduce job. It writes a MapReduce job for you. Everybody knows SQL, or most of the people know SQL. That's why people like Hive, and they write Hive queries, and that automatically makes a MapReduce job. Similarly, there is another language called Pig. Pig is also a high-level language. It's not based on SQL, but English-like commands, like filter. I want to filter the data, I'll write filter. If I want to group the data, I'll write group by. So all this kind of, it has its own syntax, but more English-like language. And once you write that, it will automatically produce a MapReduce program for yourself. So these were two programs, kind of tools which were written to make Hadoop easy, or MapReduce easy for non-Java developers. Even if you don't know Java, you can still use MapReduce by using Hive or Pig. Got it? So Hive was created by Facebook. So they created these tools and gave to the open source world. So that's how most of these tools have come. They're open source, they're created by some company and shared. The middle two box, these are something mostly used by data scientists. Remember I was talking about data scientists. Apart from other things. Thing called is machine learning. There is one tool called Mahout, which is used for machine learning. There are many of them. Nowadays, it's a machine learning war going on right now. Every company is coming up with machine learning. It's very much in demand. As the buzz on the hype on machine learning is the top level. There is a graph which I can show. It is on a peak level. So everywhere you hear machine learning. So there is Google machine learning, Microsoft machine learning, Amazon machine learning. These are companies giving machine learning. Mahout was the original Apache's version of it. The reason I picked all this because these are all free and they are the original Apache Hadoop, now Apache's project. So that's what they are. But there are other companies or other tools which may be doing similar things. That's for machine learning. Then R is a statistical language used by years and years by data scientists and statisticians. This R connector was created to connect to Hadoop and really do some MapReduce on top of those things. So these are the central processing languages which we have. There is a color coding going on. I'll explain that once I go through everything. There is a color coding, and we'll connect back to the previous slide which we have. Now, these are something which an administrator does. So when a project starts, when we have designed and thought about this is what you're going to, somebody's going to create the cluster, right? The 50-node cluster somebody's going to make. That person is called the administrator. He's going to get those 50 machines. He's going to install things on top of it. So to make that happen, we use all these tools, Ambari, Zookeeper, Uzi. So he'll use Ambari or something similar to install things. He will use Zookeeper to coordinate all this zoo. If you see this whole thing, it's become a zoo, right? There's an elephant, there's a pig, there is a bee, all kind of strange animals, right? It's become a zoo. So you need a Zookeeper for that. There is Uzi. Uzi is something which helps you schedule the jobs. So you write hive job, pig jobs, one after the other. How do you schedule? But this is going to be used by the administrator, not by the developers. So that is the red mark. That's why for the administrators. The list is edge-based. Edge-based actually, in my mind, does not belong here. It's in the category of databases. So there are many databases which have come recently. There were relational databases, which was the SQL world which we had, the Oracle, MySQL, SQL Server, all that. And nowadays we have something called as NoSQL. You may have heard of NoSQL, columnar databases. So there is a whole category, and there are hundreds of them. And edge-based happens to be one of them. So it's another way of storing data. Another way of storing data for especially distributed systems and faster processing. So those whole things make the whole ecosystem. So let me kind of recap in certain ways now with the color code. The color coding is this. I told you two things are there. There is a storage and there's processing. The things is storage, the edge. DFS, edge-based. They are storing the data. If you create a file that is going to go in HDFS, maybe they will create a table in edge-based on top of it. So those are the storage things. The middle yellow is all processing, whether you do MapReduce-based Java processing or SQL-based Hive processing, right? Or R-based statistical processing. It's all processing. So to bring back to that original slide, there is storage, there is processing. The other pieces are auxiliary or supplementing that to build a cluster and all that. These are operational things, the red color. And the blue one is ingestion, which you ingest the data, bring the data into Hadoop. So that's how the color coding is going on, and that's how you should understand instead of understanding 20 pieces or 10, 12 pieces of technology. No, that's not the case. You group at that level, and then your mind will not go insane. So that's why I was showing the storage and the processing part. I know it's a busy slide, a lot of information, but hopefully you start connecting the dots, like why are these pieces are there, and together all these pieces make a very powerful solution. You need to ingest the data, store it, do some processing using any of these technologies, and make your Uber or your Facebook company.